Hi, welcome to Advanced Math, Chapter 12 on Vectors, Part E, Page 3. So in the last page, we found a vector that represented the post holding up the roof of the bird cage. And now our job is to figure out an equation for the plane that represents the roof itself. So using the vector that we came up with on the previous page, we want to write an equation for the perpendicular plane. And you may remember that there's a simple technique for that. We'll take the components of the vector and use those to write the coefficients of a plane equation where we don't know what D is, but we do know the numbers for A, B, and C in this equation, AX plus BY plus CZ equals D. And so we just plop these numbers in, and we have most of our plane equation. Now, in order to figure out what this value of D is, we need to know the coordinates of a point that lies on the plane. And the one point that we do know lies on the plane is the point at the top of the post. That was easy to figure out from the components of the post's vector. And the coordinates of that point happen to be the same as the components of the vector. And therefore they're the same as the coefficients A, B, C, and D of the plane equation. Now, if we had chosen a point other than the base of the post to be the origin of our axis system, then these numbers wouldn't be the same, but the end result would be the same. So what I want to do is figure out the value of D. So I'm going to take my plane equation and substitute in for x, y, and z the coordinates of the point, which is the top of the post, which happen to be the same number. So it's going to be -3 times the x value, which is -3, plus 2 times the y coordinate, which is 2, plus 10 times the z coordinate, which is 10. And that's going to be 9 plus 4 plus 100, or 113. So the value of D in our plane equation is 113. So finally, we can write the complete equation for the roof, which is -3x plus 2y plus 10z equals 113. Alrighty, now let's use that to figure out something practical about our bird cage. What we want to do, so the equation of the roof relates the x, y, and z of any point that lies in that plane. And if we want to know the height of the roof at the corners of the roof, we really want to figure out what the z value is if we know the x and the y coordinates for the corners of the roof. So in thinking about that, I'm going to draw a little picture kind of a map, if you will, of our bird cage. Bird's eye view looking down. Here is the center. This is where the base of the post is. And our axis system says this is east, this is north. So our x coordinate is pointing to the right, and our y coordinate is pointing up. And our z coordinate's actually coming up out of the page. And this is a little different than the way you learned how to draw an axis system for 3 dimensions. However, this is still a right-handed axis system. So it's going to work okay. So we're just basically taking that picture that we normally have of the x coming out at us, and we're rotating that around so that the z is coming out at us, or up at us if we're looking down on this thing. And I know the corners of the roof, A, B. If you are not sure where I'm getting these from, you'd have to go back and look at the picture of the bird cage that identifies the 4 corners of the roof. And we have dimensions for the foundation. This is 16 feet, and this is 18 feet. So that enables me to write the coordinates for the four corners of the roof. So again, if the center is the origin, that makes the coordinates at point A the x and y coordinates, just for the moment. The z is going to be 0, so I can write the coordinates at the base here in x, y, and z is going to be -8, -9, 0 at the base on the floor. So -8 because that's half of 16, -9 because that's half of 18. And the b floor coordinate is going to be -8, +9, 0. The c one is going to be +8, +9, 0. And then the d one is +8, -9, 0. All right. And over here on the left, I'm going to basically fill that information again. And at this point, I'm really only looking at the x and y coordinates. So the coordinates for x and y coordinates for corner A are -8, -9. For B, it's -8, +9. For C, it's 8 and 9. And for D, it's 8 and -9. Now, to figure out what Z is, I need to evaluate or solve the plane equation for Z given this x and y. And so an example of that would be I'll write out the plane equation. Plane equation is -3x. Well, the x here is going to be -8 plus 2y, where the y is -9, plus 10z equals 113. So you have 24 minus 18 plus 10z equals 113. So solving that, we're going to get z equals 113 minus 24 plus 18 over 10, which is about 10.7. So easy peasy, we just keep doing this for the other corners. And if you got the idea here, this is all I'm going to do for the rest of this video. -3 times -8 plus 2 times +9. So these equations I'm writing out are a little bit different each time because although the 8 and 9 are the same in every case, the signs are ending up different. So everything's going to be a scooch different each time. And we don't have tons of room here, so z equals and that's going to evaluate to about 7.1. And continuing. Z equals 113 plus 24 minus 18 over 10, which is 11.9. And then finally for D, we have -3 times 8 plus 2 times -9 plus 10z is 113, which is -24 minus 18 plus 10z equals 113. Z equals 113, 24 plus 18, over 10, 15.5. All right, now does this make sense? Well, remember that the height of the center post is 10 feet and the roof is tipped at an angle. So I would expect that the heights at the corners of the roof would cluster somewhere in the neighborhood of 10-ish. And we've got A at 10.7, B at 7.1, and C at 11.9, and then D at 15.5. So if you go back and look at the picture on the first page of the section showing the cage, remember that this corner And the whole idea here is because this pole is tipped backwards, this corner, which is the one facing the people coming to the zoo, this corner is extra high so that you have this great visibility of the whole space, a very, very large uh, viewing area as you approach the cage, and the back is much lower. So these numbers kind of make sense that at the front of the cage at point D, it's really wicked high. It's kind of medium high at C and A, the two corners adjacent to D. And then in the far back of the cage, the B height is 7.1 feet. And that kind of makes sense. All right, next up, we're going to look at the lengths of the roof edges.